In this presentation, I'm going to introduce you to memories, specifically the RAM memories and the ROM memories. Then more specifically to the address bus and the data bus and the control bus. So from here, I will discuss the different types of RAM memory that you get, the different types of ROM memory that you get, what is a read cycle, what is a write cycle, and also look at the timing diagrams for reading and writing to these specific devices. I will go into more detail on RAM and ROM memories. First of all, let's just see RAM, and I will come back to that again, stands for random access memory, and whereas ROM stands for read-only memory. Now let's just quickly look at what's happening with a RAM memory. First of all, I said here it's a volatile memory. What that means is if you remove the DC supply on a RAM memory, whatever you had in the RAM memory will be lost, it will be gone. So if you want to keep the data inside this RAM memory, you must keep the power source connected to the RAM memory all the time. And the next thing I've said here, this is an infinite read and write cycles. So in other words, you can program this RAM as many times as you like, and you can also read from it. So you can write as many times as you like, and you can also read as many times as you like without any destruction or any problems at all. This is also a device which it's quite fast, because you only need to change voltages, which I will explain at some other stage, but it's a very fast device. If I go to the ROM device, it says here it's a non-volatile memory, meaning if you remove the DC power source, the data will remain. That's what non-volatile means. So the data will stay there. So in a ROM memory, you will program it. You can remove the DC source, and the information inside this ROM memory will still remain. Even if you connect it back to the circuit, it will still be there. The limitation on this thing is you've got limited write cycles. Depending on the device, it could be maybe 10,000 write cycles, which sounds quite a lot, but if you keep on writing to a device, you can actually destroy it within a few seconds to a specific position. But once you've programmed this, you can do infinite reads from it. So that is unlimited, the amount of reads that you can get. But I will explain a little bit more on on ROM and RAM memories in the next slides to follow. Okay, so let's look at this RAM family. I don't want to go into too much depth here. I am just quickly going to tell you about an SRAM and a DRAM, S for static and D for dynamic RAM. Just the quick differences between the two, and that's all I want you to know. So if we look at the static RAM or SRAM, basically what happens here is that your data is stored in a latch, and it can, in other words, the data can stay there inside this RAM indefinitely as long as DC is applied, as a DC source. What also happens here with this SRAM is data read is quite fast compared to the DRAM. And if we look at the DRAM, the dynamic RAM, your data inside the dynamic RAM is stored in capacitors. And the disadvantage here is that you need to constantly refresh the capacitors to keep the data. So, but the advantage of this specific DRAM is that you can store more data on one chip compared to the SRAM. So that's basically the differences between the two. And the disadvantage then will be opposite to the SRAM, which is that it will read slower. Data can be read slower, or the data read cycle is slower than with this SRAM. So let's look at the purpose of a read-only memory, or in short, a ROM. A read-only memory is normally a memory device which you will program some data or maybe instructions to a microcontroller. And then what you would do is you would normally just read from that memory. In some cases, in some of these cases, I'll discuss that, it is possible to reprogram it, but especially the first two, you cannot reprogram it. You program it once, the mask ROM is programmed once, and the programmable ROM is also programmed once. And once it's programmed, you cannot reprogram it again. So if you look at this one was normally programmed in the factory. So you as the designer or developer would send the program to the factory, and they would program it. Once programmed, it's a OTP, it's called OTP, one time programmable. You cannot reprogram it again. The same with this one. Only difference is you don't have to send this, you didn't have to send this to a factory to be programmed. There was a device that one can use to do the programming with at your own factory or at home. Then basically this erasable PROM, that's what the E, erasable, that's what the E stands for. The two different types of erasable or EEPROM is the UV EEPROM and the EEPROM. So in this specific case, it is possible with these two devices that you see on the right hand side, it is possible to reprogram these devices. So it is possible to program it, and later if you want to change some data or the program inside, you can do so by just reprogramming it. So this EEPROM consists of basically these two types. Now if you look at this UV EEPROM, this was an old type of device which had a window on top of the memory chip, and if you could shine a specific light, the UV light, on this window, it would erase. It's around about 15 minutes that you put this UV light on that window, and afterwards it will erase the program or the data, whatever is programmed in this EEPROM. All you had to do then is to cover that window so that no UV light can come in, specifically sunlight can come in there, otherwise it will also destroy the memory. This is an electrically erasable programmable read-only memory, and this is a device that is used nowadays. You can buy this from any reputable electronic shop, and we are still using it again to store data and also to store programs in. In this specific, Floyd, they did not mention that, but there's another one which is also a type of EEPROM, but it's called a flash ROM. In this specific case, you can erase the data one position at a time, whereas with a flash ROM, you can erase data in blocks, which is a lot faster. So two different types doing the same thing. So let's start by looking at a RAM device a little bit closer. And if I talk about RAM, you'll see that I can also talk about ROM, which there will be a slight difference between the RAM and the ROM, but we'll discuss this just a little bit later. But what's important about this RAM device, first of all, just look at this 32K. That actually means there are 32 times 1024 positions available where data can be stored, and the data length is actually 1 byte, which is 8 bits. That's why it's a 32K by 8. That's the number of positions that you've got, and the width of the data is basically 8 bits. You'll always see that what you see here by 8, it will also refer to the number of output pins on the specific device. So there are basically 3 very important buses in a RAM device, and that's actually that is true for all devices. Some maybe are missing some of these buses, but the RAM as it stands here basically is a good example of what different types of buses you can get. So first of all, we get address lines, which is normally connected to the address bus, and this address bus will be connected to your microcontroller. Doesn't matter which type of microcontroller, that could be a PIC or an 8051 or whatever, but there's an address bus. But what's important to me, I just want you to look at this at this stage. You can see that this address bus is ranging from A0 up to A14. And if you look at this, in other words, we've got 15 address lines here, 15 address lines in this address bus. Now if we look at this 15, 2 to the power 15 is equal to 32K. And that's why if you've got, let's say, something like a 16K, you will have 14 lines going from A0 up to A13, the biggest one here, and so forth. If you've got an 8K, you will have 13 lines, and if you've got 13 lines, it will go from A0 up to A12. So that's the relationship between the address lines, the number of address lines, and your memory size, the positions, amount of positions inside this RAM memory. The outputs, as you can see, there's also then a data bus, and this data bus refers to inputs or outputs depending on what you are doing. If you see this as inputs, that means data will come from the external world into this device, and it will be stored somewhere in this memory, and this somewhere in this memory will be determined by the address lines. If you look at this data bus and we talk about outputs, if this is converted into outputs, that means data will come from a specific position again, which is decided by this address bus here, address lines that specify the position, and that data will then be pushed out to the data bus and it will become outputs. So we can either read data into the device or we can push data out of the device. Let me rephrase that. I can read data from the device or I can write data to the device. Now, so this is first of all the address bus, as I've said. This is the data bus, and then there's also what we call a control bus, and this is normally what you will see here. Now, first of all, this CS stands for chip select, and as you can see, it's got a bar on top of it, which means it's a chip select low. So a low pulse is needed, or a low level digital level is needed for this device to become active. So I need a 0 here, which will make this device active. And if the device is not 0 here, irrespective of what happens on the address bus or the data bus or whatever happens with these two pins here on the control bus, if the chip select is a 1, this device is deactivated. But if it's a 0, this device becomes active. Now we've got these two pins here, which is the WE, which stands for write enable, and there's also the next one here, which is the output enable. Now output enable can be replaced in certain devices. You will see it's going to show as RD for read. So output enable and RD is the same thing. In some devices, like this one here, says WE for write enable, but it could also be WR, which is the same function of write. Now if I want to, let's say I want to read from this device, then I want to make this pin, the output enable or the read pin, low, and then I can read from the device on the data bus. But at the same time, the write enable must be a high, because I cannot tell this device to read and write at the same time. Only one of these two pins can be a 0 at one specific moment. So if I want to read from the device, I'll put a 0 here on this pin, and a 1 here. And if I want to write to the device, I will put a 0 on the write enable and a 1 on the output enable. So that determines actually the input or output of data flow into this device. If it's a write enable, data will be written into the device. If it's an output enable, data will be read from the device out on the data bus. And again, the address bus, the address lines determine which position are we going to access inside this device. So if I can just quickly look at this EEPROM. As you can see, it says there this is a 2048 by 8, which is actually a 2K by 8 EEPROM, or a ROM type of device. And if it's a 2K, of course, how do we get to 2K? It's equal to 2 to the power 11. And this is why your address bus, similarly to the RAM, but the address bus in this case will range from A0 up to A10, which is 11 lines. So this is why we've got 11 lines for a 2K device. And again, by 8, as you can see here, by 8, there will be 8 output lines. But as you can see here, they just basically refer to O for output. So generally, once you connect an EEPROM into a circuit, it's already programmed. And this is why you've got a program pin here, which is sort of the program pin replaces the write pin, the WE or WR pin. And this is why that pin will be activated with a special programming device, which you have to use to program this EEPROM or EEPROM. So basically, in this specific device, we've still got the address bus, we've still got a data bus, we've still got the, in this case it says CE, chip enable line, and the output enable line, which is the read line. So normally, once this device is programmed, I will enable the device, chip enable, meaning put a 0 on that specific pin, and it will activate this device. And normally then I will just read by pulling this line low, the output enable. I will read from the device, and again the address bus specifies which location do we want to read, and that location, whatever that location or position is, that data will be put on the address bus and be used further in, let's say, a microcontroller. Now this slide is demonstrating a read operation. Now this could be from a RAM device or a ROM device, any one of the two. As you can see, this is just a representation, and it uses 3 address lines from A0. It will be from A0 to A2, 3 address lines, and you've got 3 address lines, then that means there are basically 8 different positions where data can be stored in, 8 different registers where data can be stored in. Now in this specific example here, it says there, let's apply an address code of 011, which is 3. 011 is 3, so we'll have to go to address register address number 3, which is that one indicated in blue here. And also it says the read line is active, or the read command is applied, meaning that if we look at the previous slides, your output enable or the read line will be pulled low, meaning I want to execute a read command. So then what's basically going to happen, this blue data, this blue register indicated here, will be placed on the data bus. It says data register, and this will go out to the data bus in any case. So if you can see 11 with all zeros and another one, 11 all zeros and another one, that's the data that was read and placed on the data bus. This was the address, and that's why number 3, data address number 3, the information there is placed on the data bus. As I've said, this could be a read from a RAM device or a ROM device. What's important to remember on a read operation is, once the data is read from a specific position inside your memory, that data remains there. It does not disappear. So yes, it will be placed in the data register, and you can read this data from the data bus, but the original data remains inside the memory. You did not change that. It did not disappear at all. It's still there. Okay, let's look at a write operation, which is going to write data. This is the data which you will find on the data bus, and we want to write this data into the memory device. Let's see how that's going to happen. So it says here, the first thing you have to do is place the address register on the address bus, In this case, it's referring to address number 5. 101 is 5, which means again there's only 3 lines, which is not possible in real life, but this is just for explanation purposes. But as soon as you activate address number 5, it will actually refer to this line here, which is blue. Inside this register is blue. It's just indicated as a blue. And there's also, it's a byte organized memory array. So the next thing I would like to do, as it says, the data byte is placed on the data bus. So this is the data that must be placed on the data bus, because that needs to go into the memory device. First the address, then the data, and then number 3 you can pull the write line low, which will then activate this device. This data will be pulled into the specific memory and be placed at the address as specified here. And that's how you write data into a memory device. Okay, let's look at how we typically read and write, the typical read and write cycles for RAM memory. In this specific case, your x-axis will be the time axis. So the very first thing you have to do in this case, let's first of all look at the read cycle. That means your read line will be pulled low, which means the write enable line or the write line will be a high line. So if I want to read from the device, I will place the address. First of all, place the address so the address becomes valid on the address bus. A little bit later, I would like to pull the chip select line low, as you can see there, and the output enable, which is the read line, I also want to pull that low. So it doesn't really matter depending on your microcontroller, but of course these two actions cannot happen at the exact same time, but they can be quite close to one another. So, but pull down the chip select to activate the device, pull down the read line to indicate that it's a read action. The address is already valid, as you can see there, and then you just have to wait a little bit. It says the TGQ, which is a certain that specific time frame you'll get in the data sheet. You'll just have to wait a little bit before the data is valid on the data bus. If you try and read the data beforehand, before that time, you're going to read, as you can see there, a lot of nonsense, and it could be quite devastating if you read these nonsense and try and put that on your system. So just wait a few. It will actually normally be very short periods before you read the data. In a microcontroller, normally once you've pulled the chip select and the output enable in the 8051, the microcontroller that we use, it normally takes a microsecond or two before we start reading the data, which is way more than enough time for this data to become valid. So it's not really a big issue. So if I want to write to the device, similar story, I have to put the address, get a valid address on the address bus, and a little bit later I can pull the chip select down low, and then also as soon as the data became available, just wait a certain time period before you pull the write enable line low, and now we can basically write the data. As you can see here, this is the valid data which I would place on the data bus. I would normally prefer to put the data on the data bus right in the beginning, but as you can see here, there should be valid data, and this is why there are certain time frames that you have to wait, and at some point the data will be written into your device, and it will be stored after a certain period into your device. So these are basically the read and write cycles of your device. But in a microcontroller, as you'll see in slides to follow, not in this presentation but other presentations, you will see that a lot of these actions like the chip select and the output enable and these things will happen automatically. It's actually connected to the microcontroller, and it will happen automatically as soon as you give an instruction either a C or an assembly instruction, a lot of these things will happen automatically. So you don't really need to bother about this, worry about these, what's happening with these cycles. Okay guys, this is then the end of this presentation on introduction of memories, address bus, data bus, and the control bus. If you've got any queries, any questions, and you're at Pretoria campus, you can email me at motonajj@tut.ac.za, and if you're on the eMalahleni campus, you can then email Professor Jordan on that side. Thank you, and stay safe.